Okay guys, today we're going to show you how to balance a chemical equation. And what we mean by that is we are going to make every element have the same number of atoms on both sides of the equation. Now when I say both sides of the equation, I mean on either side of the arrow. Okay? This side over here is called our reactants. That's what we start with. This side over here is called our products. That's what we're producing in the chemical reaction. So when I say both sides, it's separated by the arrow. So let's look and see what we have here. We have CH4, that's methane, reacting with oxygen to form carbon dioxide and water. Now let's count the atoms that we have. If we look on this molecule here, I have one black carbon atom. Okay? Over here, I have one black carbon atom. So our carbon currently, we have one on either side of the arrow. Let's look at our hydrogen. 1, 2, 3, 4 hydrogens on this side of the arrow. Over here, we have 1, 2 hydrogens on that side of the arrow. If I have 4 on one side and I have 2 on the other side, that equation is not balanced. Okay, so what I'm going to do is I'm going to introduce another water molecule here. All right? So now I have 1, 2, 3, 4 hydrogen atoms, and I still have 1, 2, 3, 4 hydrogen atoms on this side of the equation. So our hydrogen now is balanced. Okay? So, but by changing the hydrogen here by adding the water, I've also changed the number of oxygen molecules. So let's look at our oxygen on this side. I have 1, 2, 3, 4 oxygen molecules. Over on this side, I have 1, 2 oxygen atoms. Okay, so in order to make those the same, I'm going to introduce another oxygen. So now I have 1, 2, 3, 4 oxygens on the right, or the left side of the arrow, and 1, 2, 3, 4 oxygens on the right side of the arrow. So now they're the same, okay? So now that we've visually balanced the equation, let's put the numbers in front of our compound with our chalk. So I have one CH4 molecule here, okay? I have 2 oxygen molecules here. I have 1 carbon dioxide molecule here, and I have 2 water molecules here. So I put a 2 in front of the H2O, and I put a 2 in front of the oxygen.
Mr. Sands, you have just a 1 though. You said there was a 1, but I don't see the 1.
Okay, if there's nothing there, it's kind of a pretend 1. If you want to put a 1 there, that is perfectly acceptable. If you want to put a 1 here, that is perfectly acceptable. Usually though, if there's a 1, we just leave it blank. So blank means 1.
Mr. Sims, what are you doing?
I'm balancing.
You're balancing.
Yes.
Oh, hey, we're talking about balancing chemical equations.
Yep.
You're not very good at that. You're moving around a lot.
It's because I don't exercise.
Well, I'm not sure I could do it well either, because balancing is like its own skill set.
It is.
So, okay, guys,
All right.
we're going to learn about how to balance chemical equations today, okay? So the goal is we want to have the same number of every atom or polyion on both sides of the equation, like you saw in the introductory video clip. So that's what we want to do. Okay. So, and we're going to learn how to do that. Okay, folks, it's accomplished by changing only the coefficient. Oh, there's a new word, not the formulas.
Yeah, guys, the coefficient that's the big number that we wrote in front of the chemical compound. Okay.
So we had 2 H2Os.
Right.
That's this number. Right.
You never change the formula of the compound.
Right.
Ever. Once you write it down, it's there for good. You never change it. You only put coefficients in front of the numbers. For example,
what he means by that is oftentimes you might see H2O and you say, well, I need 1 more oxygen, so I'm going to put another 2 right here.
No!
You cannot do that.
Never.
Why can't you do that? Because what that does is that changes. This is a different chemical. This is hydrogen peroxide.
That is not water.
And this is water.
That's
They're
right.
totally different compounds, so you can't do that.
Can't change the compound.
The only number you can change is the number in the front. It's called a coefficient. In math class, you probably understand that. If you have a 2x, the 2 is the coefficient in algebra, right? So it's the same concept. Okay. All right, so I think we should just
let's do
some examples.
Hey, that's the one we just did.
That was easy, right? So it's CH4. Let's just look at it more graphically. Here we have 1 carbon.
Yep.
1 carbon. That's good.
Yeah, that's good.
I like that. Okay. And then I'm going to do my H's. I got 4 H's, and on this side I have 2 H's right here.
Yeah.
That's not good.
Nope.
So I'm going to change the coefficient. Put a 2 in front. I got this little line here to help us kind of know where to put the line. And that gives me a total of 4 hydrogens on this side.
Yep, the 2 times the 2.
And my carbons were good. Now let's do the oxygens. On this oxygen, on the right side, I have oxygens here. Now, I have only 3 oxygens on this side, Mr. Sanders.
No.
What do you mean?
You have 4.
How do you get 4?
Because the 2 on the coefficient of water applies to the oxygen in the water.
Important to note, guys, O2, that's 2. But this 2 right here multiplies the water by 2. It's like a parentheses, if you will.
Yeah, it's like distributing.
It's a distributing, yeah. So there are actually 2 oxygens in 2 different water molecules. So hence you have 4 O's. And to fix that, you'll put a 2 here. Does that make sense? Yeah. Okay. Let's do another one. All right. Ca plus N2 makes Ca3N2.
Okay.
Okay, I got 1 Ca. That's good.
Mm-hmm. But you got 3 on the right.
Oh, well, I'll just put a 3 right here.
Yeah.
That works. Okay. And I got N2, and I've got N2.
The end.
That's good. You know one thing I like to do, guys, and just when you're first learning to balance equations, I think it's actually good to put the 1s in. Yep. Later on, maybe you can leave those out, but I think it's a wise thing to do that, just to kind of learn how to do that. So it's 3, 1, 1. Yeah. And actually on our test, probably when we have you balance equations, we'll probably have you put the 1s in.
Yeah.
Just to illustrate that. Okay. We've already done that one.
We just did that one.
Yeah.
Is this a duplicate slide?
Must have. Oh, here we go. Here's the third one. We'll just do this one down here. All right, so potassium chlorate is what this is.
Yep.
Okay, my K's.
Okay, 1 there.
1 and 1. Hey, that's good.
That is good.
Cl, 1 and 1.
Yay!
We are rocking.
Yes, sir.
Oxygen, 3 and 2.
Oh, okay. 3 and 2, guys. If you ever have 3 and 2, make them both 6.
Yep, gotta make them
always,
6.
because 6 is the lowest common multiple of 3 and 2.
So what do you mean by So I'm going to make this a 6 right here.
No, you don't change that number. You only put coefficients.
Yeah, I can only put something in the box up here. So to make that a 6, I have to make that a 2.
Yeah.
And to make this a 6, I have to make that a 3. But Mr. Sams, that kind of screwed me up, though.
Yeah, it messed up your K's and
I had
CLs.
the K's and CLs were happy. Now they're like unhappy.
Yeah, well, we can fix that with a.
Now, how many K's and CLs do I have?
There's 2 K's and 2 CLs there.
So if I put a 2 here, it fixes it.
Yeah, you're done.
Yeah. You see, you just try to get them to balance out.
Yep.
All right, how about this? Na plus Br2. Na?
1 there.
I'm happy. 1 and 1.
1 there.
I got 2 BRs, and I got 1 BR. Not happy, so I got to put a 2 here.
2.
So that makes 2 NaBr. Oh.
That changed your NAs.
By the way, when I did that, that locks the BR2 as a 1.
Yeah.
But it changes my NAs, and I have to go back and fix it by putting a 2 there.
There you go.
Yeah. Okay. All right.
More examples.
Oh, here's a little trickier one.
Oh, that's fine. Okay, guys, when you see a polyatomic ion that appears on both sides of the equation, you can treat it as a group.
Yeah, actually, here's what I like to think of it. Think of SO4 as a circle.
Yep.
And SO4 as a circle. Now, there's 3 circles on the right side, and on the left side, there's just one. Okay, and so...
Put a 3 there.
Yeah. So what we're going to do is... All right, so what should we do first?
Put a 3 in front of the H2SO4.
Why?
Because we have 3 circles on the right, we need 3 circles on the left.
So if I can put a 3 here, that's like having 3 circles. Now that's going to give me, so that fixes this one. That makes this have to be a 1, right? Yeah. So that's going to now mess up my hydrogens. How many hydrogens do I have on the left?
That's 3 times 2, so 6.
6. So if I fix the 6 by putting a 3 here, I'll get 6 H's. Now let's count our O's. Not the O's in the sulfate, but just the O's.
Because we've already taken care of the sulfate, the circle. So the free oxygens that are out there, we have 3 on the right and 3 on the left.
So, hey, that's what I want.
That's done. And there's 2 irons on the left and 2 irons on the right, so that's done.
There's this kind of thing, guys, where you kind of go back
and forth.
And forth and back and forth. You just keep checking one element, or in this case, a group of elements, a polyion at a time.
And guys, one trick that I like to use when I do this is I always start with the most complicated substance in the reaction.
Which was this one here.
Work from there. If you do that,
usually
you'll be
works.
fine.
Sometimes you got to double things.
Yeah.
But okay. All right, let's take a look at this one. This one has one of those kind of, well, this one is not so easy. I don't see anything the same at all.
Let's start with the most complicated substance.
I think this is most complicated,
it looks pretty complicated to me. All right.
We got NH42CO3.
Yeah. And okay, so let's just start with the nitrogen.
Yeah, I think we have to do element at a time. We can't do groups here.
We can't do groups. So
there's, now, guys, there's an NH4, but this 2 multiplies everything in here by 2. So how many N's are there?
There's 2 nitrogens in there.
And on this side, I just see N's in this guy right here. So that means I got to put a 2 here.
Yep.
So if this is the case, we're sort of assuming that this is going to be a 1. We may change this.
We may. Okay, let's do carbon next. Here's another trick that I do, guys. Start with the non-hydrogen, non-oxygen elements. Balance those first, then balance hydrogen, and then balance oxygen. Sometimes you'll do oxygen and then hydrogen, but usually I like to do oxygen last. It kind of...
Hydrogen and oxygen are your last things to balance.
Yeah.
Usually. Okay, so carbon. I've got 1 carbon and 1 carbon.
Okay.
Hey, I'm going to put that at 1.
Okay.
Let's go with the O's.
Hydrogen.
You do hydrogens? Okay. Hydrogens. How many hydrogens? I got, now here I have 6. And here I have 2.
So that's a total of 8 on the right-hand side.
Yeah, so this is 8 total. And over on this one, I've got 4 times 8.
2. Hey, that's 8 there. Hey, that's done.
We're good. Okay,
Okay.
hydrogen's good. Now let's check our
Oxygen.
O's. I got 3 O's on the left.
Okay.
1, 2, 3 O's.
Hey, we're done.
So that makes this a 1.
lock it in with the
All
one.
you needed to do is put a 2 on that NH3.
That was nice.
That was pretty easy.
It looked harder than it was.
Yeah, it wasn't too bad.
See, most of these guys, they're going to look harder than they really are. They're not
All right.
so bad.
How about this one?
All right, let's start with the most complicated thing.
I think that's aluminum oxide here. Yeah, 2 and 3 there. Okay, so
All right.
let's do the
Start with the aluminums because we do oxygen last, right?
Okay, so we'll put a 2 here.
Okay.
Okay, and that makes this a 1. And then I got 3 here and 2 here. Oh, that's
man.
that 6
The 3 and
thing.
2, we got to do the 6.
So that's going to make this a 2, and then this a 3, but that screws up my aluminum.
does,
so this
yeah.
2 is actually not a 2, but a 4. You see how we kind of went back and forth, and then even the oxygen last thing didn't work very well.
Yeah, you got to work through them.
Yeah, just got to work through them.
Now, guys, here's something you should probably know. We've been doing this a long time, and
me a lot longer than him.
Yeah, a lot longer. And we still have to work through these. Okay, we don't just look at it and instantly know. Some of them we can look at and know, but it's a problem that has to be solved, and there's a process that you'll see that we're going through every time we approach an equation that we've never seen. We go through the same process. We start with the most complicated.
Yep.
We just go back and forth until they all balance out, guys. If you use the process that we're teaching you, you'll be able to go through these. No problem.
It's kind of like a little puzzle, really.
It is.
So a lot of kids seem to like this.
Yeah.
Now let's actually talk about this type of reaction. Later on, we're going to learn about this is what we call a combustion reaction, which is what we did with warming of the fire and all that kind of stuff. But this is whenever you have a CH compound and you're reacting with O2, I like to use what I call the CHO2 rule. That means you balance your carbons first, then your hydrogens, and then your oxygens. And then if it doesn't quite work out, you double everything. The 2 stands for double. Okay, the double. And that's what we're going to do here. All right, so I know this is a combustion reaction. We're going to learn about that, I think, in our next podcast.
I think so.
But let's kind of figure this out. So I have carbons.
Okay, there's 2 there.
Dos and uno.
There's
so
1 there.
I'm going to put a 2 here.
Okay.
By the way, when I do that, I like to put the sort of lock in that as a 1. I might change my mind and double it, but right now I'm going to leave it as a 1.
Right.
Okay, now how many hydrogens? I got
6
6 and I've got 2, so I need to put a 3 right there, right?
Because 3 times 2 is 6, right?
3 times 2 is 6. Now we're going to do our O's. Now the O's, all right, how many O's in CO2?
There's a total of 4 there because of the coefficient.
Because of the coefficient. And how many here?
3.
3. So that adds up to a total of 7. So to fix that over here...
Okay. Good morning.
It's not going to work, Mr. Sams.
No, because nothing times 2 equals 7.
Well,
this is
3.5
3 and a half, yeah. Let's do the doubling thing.
Yeah, so we can't get whole numbers. We want to have whole numbers. There's exceptions to that, but right now we're going to try and remember. Let's try and get whole numbers.
All right.
So now we got to double it, don't we?
Yep.
So that means this 1 becomes a 2. This 2 becomes a 4. This 3 becomes a 6. It's kind of messy, doesn't it, Mr. Sams?
Yeah.
And then now, if you think about this,
recount them.
Recount my oxygens, because my carbons and my hydrogens are already good.
Right.
It's just my my oxygens that are bad. I'll have 8 oxygens here, 4 times 2, and I'll have 6 times 1, or 6, so 8 and 6. So that adds up to 14 O's. Well, I can put a 7 right here.
7 times 2 is
so
14.
2746 is the answer. Okay. All right. Well, I think that's enough examples for him.
You'll get
notice how messy this is.
Practice.
We're just going to have you write example after example after example, and then you're going to be so good at this that you're going to be, some of you get better than us probably.
Yep.
Well, maybe not, but maybe.
Maybe better than you.
Better than me. Yeah, there we go. Okay.